In this video, we're going to do a demonstration of an analog to digital conversion done by an Allen Bradley ControlLogix PLC. So we'll bring you down close to the PLC here first. We have a Fluke 725 multimeter. It's going to be sourcing our analog input signal into the PLC. We're going to be sourcing in a voltage range. So the analog input is going to be set up for reading in at a voltage value. So right down here we have two binding posts. They are wired up to our analog input card here on our ControlLogix PLC. You can see we have two of the inputs. We've got two of the inputs wired. They're wired up for single-ended mode. There's also a differential mode you can wire these up as. You'd have to refer to the manual for more details on that, but they're wired up for single-ended mode. So this analog input module will then take the voltage that's being sourced to these terminals here and convert it to an integer value that's stored in the PLC. So if we back up, go to our computer screen here, we're going to be using RSLogix 5000 to read the integer value that's going to be stored in the PLC. So from the computer, we have Ethernet cable connected to our Ethernet module. It's going to be reading the value stored in the controller here that's converted from voltage to integer value or digital value in our analog input card. So first let's go have a look at the tag table in our ControlLogix PLC. This is where we will find the integer value being stored. If we drill down, we want to go into card 5, local 5, I, and we scroll down. We're working with channel 0. So local 5 colon I dot channel 0. And you can see that this here is integer data. The data type here, we're on the data type, our data type column, and the data type we're working with is an integer. So in the ControlLogix system, an integer is a 16-bit value. And right now we have a value being displayed here, 15,980. So this is all coming in through our 1756 IF8 module. If you look back down here at the PLC on the front door, this is the 1756 IF8 module. Okay, so if I open this up, go to Properties, go to our configuration, you'll see channel 0 right now is set up for an input range of negative 10 volts to positive 10 volts. So that's the analog signal range. The analog signal range that's coming into that input card is set up for negative 10 volts to positive 10 volts. We can change that if we wanted a different range, 0 to 5, 0 to 10, and 0 to 20 milliamps. Okay, so we know that we have it set up. We're going to be working with negative 10 to positive 10 volts. We just want to ensure that we have that set up, and that's how we do that, is by clicking on by going into the properties and clicking on the configuration tab. Cancel out of this, and now we're going to move over to the board here. We said that an integer data type is a 16-bit value, and just to verify that, if I drill down here, you'll see all 16 of the bits being displayed right here. They can only either be a 0 or a 1. And then up here, this is our decimal value, the value that humans like to work with. This here is basically the binary value, what the computers like to work with. So we'll minimize that again, go over to the board here, have a quick look. So this is how we determine our upper and lower range value for our digital or our integer range. Over here on the right hand side, you can see our upper range value. To figure out the upper range value for our digital range, we take the number of bits, and I said it was 16 bits. So 2 to the power of 16, 2 to the power of 16 minus 1, which is going to be 15, So 2 to the power of 15 ends up being 32,768, and then we need to minus 1. To figure out the lower range value, almost identical calculation except for we do not minus 1. So we have 2 to the power of 16 minus 1, which is 2 to the power of 15, which works out to be 32,768. So our range is 32,768. Sorry, that's going to be a negative. I got to change that. So this here should be a negative 32,768 to 32,767. That's our integer range. And then over on the left-hand side, I said we're going from negative 10 to positive 10 volts. Well, I know looking in the specifications for this 1756 IF8 module, the analog input module, down in our PLC chassis, it actually is set up for negative 10.25 to positive 10.25. You'd think it would say in there, but it does not. You have to read that in the configuration. So, or sorry, in the literature for the module. So to figure out a value, we're going to source a voltage value in. We're going to source in 5 volts. So just to draw that up here on the board, this here would be 0 volts. And we're going to be sourcing somewhere right around here, about 5 volts. So if our lower range value here is negative 32,768 and our upper range value is 32,767, there's got to be 0 somewhere in this range, and it actually is pretty well the exact same spot as 0 on our voltage side. So we should have a positive value displayed in our PLC when we source 5 volts into the analog input card. So let's set up our Fluke 725 for 5 volts, and it already is. It's set for 5 volts. Let's have a look at our value here for our analog input channel 0. So local 5i channel 0. That's the base tag for the channel that we're sourcing our 5 volts into. And it's reading a value of 15,981. So using our range conversion formula, I've already just inputted our values. We've got our digital value over here on the left. This is our analog value we're sourcing in, 5 volts. This is our lower range value, upper range value, and lower range value for the analog range. And then over here, right here, sorry, we have our upper range value for the digital range and our lower range value for the digital range, minus by our lower range value of our digital range over here. So if we do this step by step, do the math, we end up with a value of 15,983. And you can see this second last step, we have a decimal of 0.6. With an analog to digital conversion, we truncate and we just drop the decimal place. So we just get rid of it, we do not round up. So there we have 15,983. Doing the math is almost identical to what the device is doing here. You can see we're off by about maybe 2, and that could just be due to calibration of our analog input module here, but it's very close. So there, we did a analog to digital conversion with our ControlLogix PLC. And to just to prove that this value changes, we're going to prove that when we source 0 volts into our PLC, that the analog value goes to, that the integer value or the digital value goes to 0 as well. So let's do that. Change this to 0 volts in, and we have right here, I'll just select what we're looking at here. We have a value of 2, right? So when we're at 5, we're getting our same value, or almost the same value that we had up on the board here, 15,983. On the screen here, it was displaying 15,983. 981, so very close. And then when we switched our source voltage to 0 volts, our integer value went to 0. I also wanted to mention this here value. If you were to do this exercise yourself, this value int stands for integer. If you're not getting that here, the reason would be that down here for the configuration for your 1756 IF8, your analog input module, it may not be set up properly. So if you right click, go to properties, I just wanted to show you this COM format right here. It's grayed out right now, but when you're setting up the card, you need to ensure that you select integer data. If you do not select integer data and it's set up for real or floating point or something else, you will not get your value displayed as an integer.